Today's class is on Amines and it is set number 18, and I am going to solve entrance exam solutions and exemplar solutions, and which are very important for entrance point of view. And you mindfully follow. First of all, I have taken one of the question which is a bit critical. Which one of the following is the method for preparation of amines which will give same number of carbon in the chain of amines as in the reactant? Means you are going to prepare amine from some reactant, and which one of the following will give the amines with same number of carbon of the reactant. Whatever the number of carbon in the reactant, the amine will have same number of carbon. Which of these reactions of nitrile with amine? Say next one is reaction with amide. Third one is heating with alkyl halide with potassium salt of thilimide followed by hydrolysis. I will show it a bit later on. So this will give it CH2 amine. Am I right? This will also give you amine. So here number of carbon of the reactant 1, 2, 1, 2, alkyl halide, whatever the number of alkyl halide. So this is the same. So first two option is same. That is number of amine with carbon having same number of the reactant, carbon with reactant. Whatever the number of carbon in the reactant, same number of carbon is present in the amine. So these two will give the same. The option 1 and 2 are same. And third one is heating with alkyl halide with potassium salt of thilimide. So this is a very important. Very often you may find it difficult to answer this one. So you see what is thilimide. This is thilimide, and when potassium salt, you need to make it potassium salt when it is made to react with potassium hydroxide alcohol. So you will get that is potassium salt of thilimide. Potassium salt of thilimide. Now you are adding alkyl halide. So heating of alkyl halide with potassium salt of thilimide. Potassium salt of thilimide is there. You are now going to do alkyl halide. Alkyl halide, say this is alkyl halide. Say yes, alkyl halide. Am I right? So this is the reaction. You will get this. Am I right? So next step is hydrolysis. Hydrolysis, this is very important step I am showing you. Let us write it once again. I am repeating here. This I need to hydrolyze it. Hydrolyze means the shortcut way of how to hydrolyze it. I am showing you. It is a technique, shortcut way how you look at to amine. You see, you break the bond here and break the bond here. Am I right? So in upper part, we make water, arrange water in this way. H is here and OH is here, and another water molecule H is here and OH is here. What you get here is RNH2. The important factor is it is called Gabriel-Thilimide reaction. Gabriel-Thilimide synthesis of 1 degree amine. It will give you 1 degree amine. It is very important. Very often, lot of questions asked in the entrance. Here you will see that an amine is formed. It is an aromatic compound, and from aromatic thymide we have got an amine which is an aliphatic amine, and you are asked in the option whether it is aromatic amine or aliphatic amine, 1 degree, 2 degree, 3 degree. Mass, first of all, it is aliphatic amine. Second point is that it is 1 degree amine, and third point is that the source of nitrogen, another question we will explain the fag end of this class, is the thymide. From thymide you get nitrogen. And another question is asked, what is the mechanism of the reaction? It is SN2. It is a single step reaction, substitution reaction is there, SN2 mechanism. Mind that. Another point here, very often you may say that from nitrile how you will get lithium aluminum hydride, how we get amine RCH2NH2. One of the simple trick I will show you here. You see that is a lithium aluminum hydride. When it is a strong reducing agent, we need 4 hydrogen added. So now addition of hydrogen is called reduction. So 4 hydrogen is added. How it occurs? Yeah, 1 hydrogen adds here, another with nitrogen. 2 hydrogen is over. We need another 2. 1 hydrogen here, another is here. You see, are you not getting RCH2NH2? That is how we get this. And amine, RC or amide. In case of amide, what's happened? Only this group becomes CH2. Other things remain same. Am I right? So the first question is over. In the exams, and which one of the following will undergo coupling reactions with benzene diazonium chloride? Benzene diazonium chloride. One is aniline, other is phenol, other is anisole, other is nitrobenzene. So first of all, what is coupling? Coupling means 2 or more benzene ring will get attached. Am I right? With in presence of some reagent. But the main fact is that when benzene diazonium chloride this is benzene diazonium chloride, when it is made to react with aniline, this is aniline, this is anisole, this is phenol. Am I right? So what is the criteria for a coupling, azo-coupling reaction? The criteria is that benzene diazonium chloride is a weak electrophile. It is a weak electrophile. So it will prefer to attack the species, another species which are rich in electron. The species which it will make a coupling reaction must have some electron. Now you see the beauty of the reaction, coupling reactions. Here this benzene diazonium chloride, which is a weak electrophile, will like or preferably attack the species where the electron density is more. So the species with which it will make coupling reaction must have some group attached with it that will provide the electron density center. So you know, better you know that OH, NH2 and OCH3 has lone pairs of electron, and that enters in the resonance and it gives ortho and para electron density. Here in ortho and in para, ortho in para, ortho in para, electron density is more. These are ortho and para reacting group. So what's happened? When they are in para position, electron density is more, then this group attach, this benzene diazonium chloride attached with this one. Just you remove this chlorine and you make attach with shorter bond. I am giving you longer, you make it very short, and you remove this one and remove one bond. You are getting that coupling compound is this. Electron rich center, the attachment will occur. So when it will react with amine, then this will couple in this way. because here this point is para position is electron dense center. Am I right? When this will react with any sol, the coupling reaction will occur in this way. But the fact is that when nitrogen is attached with this one, it is in deactivating group. So in para position and ortho position, electron density will not be more. So no coupling reaction will occur with nitrobenzene. So your question is, with which one of the following the azo coupling reaction will not occur? Answer, with nitrobenzene it will not occur. Told this Gabriel Thelimard reactions. Once again, I am showing you. Please, I will write it in a speedy manner because this section is very important. This is Thelimard, and it is made potassium salt of Thelimard. Am I right? So we need to react with potassium hydroxide alcoholic. Am I right? So what you will get is this is potassium salt of Thelimard. Now, when this potassium salt of Thelimard is react with alkyl halide and followed by hydrolysis, what's happened? This is SN2 mechanism, and we get am I right? And the last step is hydrolysis, means OH and H plus. The not mechanism, the shortcut way I am showing you, shortcut way. Hydrolysis means you break the bond in this way. Water will be added in this way. One hydrogen here and OH here, one hydrogen here and OH in other part. Am I right? So you are getting this part. Answer RNH2. It is 1 degree amine. So the best method of preparation of 1 degree amine is Gabriel Thelimard synthesis. Am I right? This is very important reaction. Question looks very simple, but a critical point, a two-step point is there. So benzene diazonium chloride, when benzene diazonium chloride is made to react with copper and HCl, you will get chlorobenzene, and this chlorobenzene and nitrogen, name of the reaction is, and very often in the option it is given Sandmeyer reaction, and another is Gattermann reaction, and another is this one. You will be confused with Sandmeyer reaction and Gattermann reaction because both the name reaction will give you halo alkane, halobenzene, cyanobenzene, like this. But what is the difference? Difference with this one. If it is copper salt, it is copper salt. If it is copper salt and HCl, then it is Sandmeyer. And if it is copper powder, if it is copper powder and HCl, this is Gattermann. So you will be confused in exam whether it is Sandmeyer and Gattermann. Answer, it is copper powder, hence it is Gattermann reaction, not Sandmeyer reaction. So name of the reaction is Gattermann reaction. Each question of entrance is on concept. You are asked, out of these three, which one will react faster with HCl? Means all are amine. It is 1 degree, it is 2 degree, it is 3 degree amine. All are basic in nature because there is lone pair of the electrons. Am I right? This lone pair electrons will be readily available for the reaction or protonation like this. Am I right? So the most basic the amine is, more easily it will react with acid. So the order of basicity here, I effect plus I effect. In all the cases, all the amines are plus I effects are there, plus I groups are there, electron pumping groups are there. So electron pumping group facilitate or increases or enhance the basicity of amine. Am I right? So more the plus I group, more will be basicity. But the fact lies here, if it is 3-degree amine where CH3 plus 3I effect is 3 CH3 groups are there or 3 ethyl groups are there. So it makes crowdiness around this lone pair of electron, and this, due to this crowdiness, this lone pair of electron is not easily available for reactions, hence 3-degree is less reactive, less basic than 2-degree. So 2-degree is the highest or highly basic. So highly basic one will react with hydrochloric acid faster. So answer is this 2-degree amine will react faster with acid, hydrochloric acid. Question is very simple. So what is the product? Simple product, no explanation is required. Simple product is amine. No explanation is needed. You know it. If you can find how nitration of benzene occurs, so very often from first year also you have got when benzene made to react with HNO3 and H2SO4 both are concentrated, you get nitrobenzene. Now your question, here is the question, in nitration of benzene, which one of the following species, there are lots of species given in the option, will initiate the reaction? Means there should be an electrophile. What is that electrophile? Many of you, almost all of you know it is NO2 group. But let me explain how. You see, just I have written nitric acid as in this way and sulfuric acid as in this way. Am I right? Because a question very often asks in IIT, JEE or IIT screening advanced, JEE advanced, the question is asked in this way. That's why I am showing you what's happening here is. So you see, out of these two, you are getting water, and NO2 is plus water NHSO4. Am I right? So your electrophile is this. So your answer here, electrophile NO2 will initiate the reaction of benzene converts to nitrobenzene. Electrophilic substitution reaction occurs. You have got it. But the question, another questions in higher exams occurs that out of these two acid, which one is base and which one is acid? So here you see both are acid, but it is stronger than nitric acid. So stronger acid here, it gives what? An acid is the species which gives out hydrogen as proton is called acid, and the base is the species which gives out OH, and the solution is a base. Here sulfuric acid gives H as proton and nitric acid gives OH as in the solution. Hence it is base and it is acid. So answer of the entrance exam here, in the nitrating mixture, sulfuric acid is an acid and HNO3 is a base. You are asked the methylamine and nitrous acid gives N, on heating with water on hydrolysis gives B. What is B? And this is a question in asked in different way. And the main clue point is that amine when reacts with nitrous acid HNO2. One of the point here I need to mention is that nitrous acid is a very unstable acid. You can't find it in the laboratory to use in the bottle. You can use an HNO2 as HNO2 because you need to prepare in the course of the reaction with some other two reagents. It is called in situ preparation. So how nitric acid is prepared? Nitrous acid is prepared NaNO2 plus HCl. So what's happened here? You are getting HNO2 plus HCl. So in the preparation itself, if you mix up NaNO2 plus HCl, automatically it will give you nitrous acid, and that nitrous acid will make to react with the amine. So when nitrous acid made to react with amine, it will give benzene diazonium chloride. So what's happened here is when this reacts with this one, you will get CH3 N triple bond N and Cl and this. And here A is here this. So it is a very famous reaction. Uh, uh, when aniline reacts with nitrous acid, you will get benzene diazonium chloride. Am I right? So likewise, when methylamine reacts, it will get methyl N triple bond N Cl. And on hydrolysis and heat, it will give you methanol plus nitrogen. So this is another type of the reaction question very often asked when methylamine reacts with nitrous acid. Or which one of the following species will give nitrogen with reaction with HNO2? In option A, lots of option is there. When there is methylamine, aliphatic amine, you will find it will give nitrogen. This is nitrogen gas. This is another question where which of the following species will give nitrogen gas with HNO2? Answer HNO2. Answer is methylamine. You were asked arrange in increasing or decreasing order of basicity. So you see both are base, all are base. Am I right? So basicity of a species increase with the presence of plus I group in the compound. So if there is minus I group, that it will reduce the basicity, means lone pair of the electron will not be easily available. It will deactivate the benzene ring. So here aniline is a base, basic, it has some basic nature. Here methyl group is there, it will electron pump, it will facilitate, it will increase the basicity. So if it is 1, if it is 2, if it is 3, so 3 is the highest basic because of presence of plus I group in this one. And here this will be the least one because there is deactivating minus I group, NO2 deactivating group is there, it will be less basic, least basic, and this will be the second. So number 1 is in second position and number 2 is the least. This is the order of basicity of this. So both the reaction is very important and you must know it. When you are amide group is there and you are given bromine plus potassium hydroxide, it is Hofmann bromamide reaction, Hofmann bromamide degradation reaction, because here one group will be degraded. Which group will degrade? It is aliphatic or aromatic amine. In both the cases, one carbon less amine you will get amine with one carbon less, hence it is called degradation. When you made to react with this one, then this group is degraded. Answer is this. You are getting simple amine. Am I right? So this is Hofmann bromamide degradation reaction is very famous and you keep it in your mind. And next one, again, you are given this compound along with this reagent is not given. You are asked, the answer is given C, benzene CHNH2CH3. What reagent here is used? Answer again, bromine plus potassium hydroxide, because here this CO group will vanish out. When CO group will vanish out, here this is CH, here this is CH, and this is nothing but CH3. So CH3, and this is vanished out, and NH2 is there, means degradation of CO group occurs, and that will occur only in presence of the reagent bromine plus potassium hydroxide. So these two nitrogen in Gabriel thalamide synthesis of 1 degree amine. This is a question very often asked. What is the source? A lot of options are given. Let me explain once again. This is This is thelimite, this is thelimite, this is thelimite, and potassium salt of thelimite is formed when it is made to react with this one. Potassium is introduced in the reaction. This is potassium salt of thelimite. So next part is reactions of alkyl halide. Alkyl halide, am I right? So this is SN2 mechanism, single step reactions. What you get here is and next step is hydrolysis and heat, and this is a very peculiar and a very important reaction, and without mechanism I am showing you a trick how this occurs. Just this bond will break here and this bond will break here, and how water is introduced here is in water proton part goes here and OH is this side, proton is that side and OH is that side. Am I right? So what you get here is, you see the beauty of the reaction is RNH2, it is 1 degree amine. The reaction is so important because you were asked what is the source of Gabriel thelimite reaction. Answer is thelimite or potassium salt of thelimite is the source of nitrogen. Potassium salt of thelimite or thelimite is the source of nitrogen. Now another question, what is the mechanism of reaction? SN1, SN2, E1, E2, elimination, and lots of options will be there. Answer, it is SN2 reaction. It is a single step reaction. Third question is that the amine which is prepared is aromatic or aliphatic. Answer, most surprisingly, aromatic is all where, everywhere aromatic is there. Alkyl halide is aliphatic alkyl halide. Answer, amine is aliphatic amine. Fourth question is that the amine which is prepared either aliphatic or aromatic. Answer, aliphatic. Which is the type of the aromatic is 1 degree or 2 degree or 3 degree. Answer, it is 1 degree. So lots of question is very often asked from source of from Gabriel thelimite reaction. Thanks a lot for watching the class. It is a very important class. Hopes this class will help you a lot of in understanding the first chapter, first class on amine, and in the next class I will start with more interesting and peculiar type of questions, solution of entrance exam and practice sets. Please don't forget to subscribe those who have not subscribed to remain updated.